Okay, good morning, everyone. Thank you all for joining us for this conference. Thank you guys for having us. I'm excited really to present our research on summarizing Arabic articles using large language models. So basically, in this study, we specifically investigated the adaptation of pre-trained models, then explored how abstractive summarization works, then additionally, we explored unsupervised techniques like k-means, also latent semantic analysis to cluster all these sentences and create a coherent um, summarization in Arabic language. Let me give you a brief about, introduce you to the team members who devoted their time on this research. So basically, we are a software engineers affiliated to King Saud Universities with the software engineering department. Leading this research is Badr Shemamri, who's, okay, excuse me. Um, yeah,
Yep.
so leading this research is Badr Shemamri, who's a ex-senior data scientist at Deloitte and currently assistant professor at King Saud University, and I'm Ibrahim Al-Rayes, a AI engineer at Sky and a former teaching assistant for AI courses at KAUST. And we have Hadin Malik, who now works as AI consultant at McKinsey. Also, we have Turki Altahhan, who's a backend engineer working in one of the government entities. And lastly, we have Mohammed Mutlag, who's a entrepreneur working in, he founded Unicode, which is a company that produce a tailored technical solution for clients. Yeah, that's brief about the team members. And let's go with the challenges we faced during this research. So when dealing with Arabic language, specifically, you will come over many obstacles that maybe many other languages don't go through. So one of the things is the Arabic language processing. So basically, it's different from processing any other language. The Arabic language consists of 28 letters, and each letter has 8 different diacritics. Um, and these kind of diacritics, some of them can combine, making more and more, the letter making it more complex. So this is one of the things that's crucial to understand the text. This complexity makes it challenging for machines to interpret the meaning of each diacritic in different sentence. And this situation becomes even more complicated because some diacritic can be combined, like shadda with kasra. And for example, you can see here, guys, the letter alif, where it's shown in 8 different diacritic and it somehow has different meaning. Also, the morphology of the Arabic language, while it's simple in its root system, but it can generate complexity of words. This complexity is the reason why the Arabic language is considered to have one of the largest dictionaries. Um, so, for instance, the letter, let's say the word kataba, which is write, can be transformed to katib, writer. Then, okay, writer can be transformed to um, writer for a female or writer for in a male form. So, basically, katib, katiba. Okay, how about if we go plural, singular, duals, plurals? So, we have katib, katibun, katibin. It can generate a lot of words from this single root. So it's kind of complex, and it requires certain let's say, processing to generate less vectors yet representing the word as a theme. Um, so let's go with the other challenge that we faced. One of the major challenges we face in our research is the lack of annotated data for Arabic compared to English. Annotated data is crucial for training and fine-tuning language models, as you know, it provides the necessary context and examples for the model to learn from. Unfortunately, Arabic language suffers from a significant scarcity of such resources. So, in addition to the limited annotated data, the diversity of Arabic dialects further complicates the situation. You have the Egyptian dialect has different like format of expressing. We have the Moroccan, the Gulf, so the data could be varied between each dialect. So what we did is we 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 took we translated an English CNN. So we built a model that one modern Arabic, of course. So which is like the standard Arabic, the Fusha. So basically, we took a data that's English CNN daily meals and translate it to Arabic to augment this data into our model, fine tune it better. Then we cleanse all these translated data and make sure that only the clean and suitable um, forms of data or rows or text is will be passed to our models. And also, um, oh, sorry. And also, we utilized the AMN data set, which contains approximately 265,000 Arabic news and articles for training the models. So basically, and the abstract approach. It's basically in simple. This usually includes unsupervised analysis and so on, where we want to so these sentences, and the closest sentence to the centroid will represent the whole cluster, and depicting these the most representative sentence from each cluster, combining them together, making a summary for that, let's say, article. The other way around is to build a model that able to generate language, which is basically sequence to sequence or transformers, and that's it. So it's gonna try to. It's basically a matter of supervised learning, where you give it an article and try to predict the summary of this article. So let's start first with the extractive summarization and what we did here. Um, so basically, what we did is we took, let me show you like the pipeline. But what we did is we tried to compare two different, say, approaches here. We tried a Latin semantic analysis, and then the k-means. And with the k-means, we tried the TF-IDF vectorizer and the sentence BERT vectorizer. So basically, the pre-processing step is crucial for NLP task. So what we did is we first cleansed that or remove the symbols and special characters. Then we stem the words to its roots, because we don't want to create many let's say vectors. We want to reduce it and make it similar. Let's say the word, I don't know, let's say writer, we want to be write. So writer, writers, written, it will become to the root right. That will make the language, the model comprehend the language better, and creating less vectors. So that's why it's comprehending the language better. Then we used ISIR, Arabic Stimmer, to reduce the words with their root form, which is particularly effective. Next, we normalize the text. So basically, in Arabic language, so as I mentioned earlier about the diacritics, so we remove the diacritics. Some of the forms of letters we remove it to original form to make to generate less vectors to let the words resemble itself without any diacritics and so on. Then we tokenize the text into sentences. and then pass it to either a TF-IDF vectorizer or a sentence BERT for the k-means at least. And for the latent semantic analysis, we just did TF-IDF. Then we fit the data to the model. Yeah, so given an article here, it will depict the best sentences out of them that represent the whole text. Yeah, as I said earlier, k-means clustering groups similar sentences based on their content. So we utilize TF-IDF here and sentence BERT. We'll show you how different they are in performance. Yeah, SQL and latent semantic analysis also, which analyze relationships between words, then identify hidden semantic structures within the text. So basically, LSA helps in understanding the context and the importance of sentences by analyzing. This is so basically we evaluated the performance or extractive summarization model, A, k-means and with TF-IDF and k-means with sentence BERT. We evaluated those on ASIC dataset, which includes 153 rows of Arabic articles and their corresponding human-generated summaries. So basically, the evaluation result. And we compared it with uh, genetic algorithms, which another author wrote in his paper how genetic algorithms can live into pretty good, and our results became very comparable to, especially the k-means sentence BERT vectorizer, became very comparable with genetic algorithms. So that's it about the extractive approach. Let's look into the abstractive summarization, which involves generating new sentences that capture the essence of original text. So given a text, it will try to predict the next pods and or next tokens to generate a summary. We thought initially of building the model from scratch, but however, given the complexity and the need for extensive computational resources and large datasets to do this, we really opted for an efficient approach. So we decided to fine-tune LT5, which is an existing language model in Arabic, fine-tuned over T5, then we fine-tuned that on our specific use case. So instead of starting from scratch, we fine-tuned LT5. And this process leverages the model's prior training on a vast amount of Arabic data, thus allowing us to achieve high performance with relatively limited. So we utilized the Ayman datasets, which contains, as I said, 265K approximately rows of Arabic news articles with their corresponding summaries, and translated rows into, and the translated rows of CNN dataset, CNN Daily Meal dataset, which we found ready to go to the model. Selected these model hyperparameters, which works best for us. So basically, we selected the gradient accumulation steps to be 8 and the batch size to be 8, thus creating a batch of 64 each time the gradient is calculated. This is basically because we didn't have so basically because we didn't have the computation power to do 64 one time, so we did accumulation steps, and we did a weight decay of 0.01, introduce a penalty for loud weights, 0.05, sorry. ensuring a steady convergence without overshooting. So that configuration worked best for us. This is the abstractive approach benchmark. We compared it with a sequence-to-sequence pilot TM model. So our model 35, which is a domain-specific model to summarize Arabic articles, performed better than the sequence-to-sequence model. We can say on ROG 2, it had better precision, recall, thus having a better F1. And these are our results for the abstractive benchmark. Going next to discussion. So while our models showed a promising results, there are several limitations to consider. Um, okay. The character approach, despite its effectiveness in maintaining the original text, the extractor approach in general has a limitation because since you are extracting the sentences from the text itself, sometimes combining these sentences, which the model claims to have the better representation of the whole text, combining all these different sentences might not always produce a coherent summary. And sometimes doesn't flow naturally, the summary. That's the problem with overall the extractive methods. Um, so it's better to use abstractive approach for generating coherent summaries. But the abstractive summarization, and try to generate more human-like summaries is constrained by its resilience on the quality of training data. So having scarcity of this high-quality annotated Arabic datasets limits the model from generalize across different contexts and dialects. So if we pass it in Egyptian or Moroccan text, won't work perfectly. So our future research direction could focus on several key areas on these limitations. We might start by looking for enhanced data collection, expanding the availability of high-quality annotated dataset for Arabic, covering a wide range of dialects and domains. We might also fine-tune a larger model with these new fine-tuning methods such as LoRa and XLoRa, um, taking a more efficient route to fine-tune. We might our next steps maybe try to build a domain-specific models to tailor the models to specific domains such as legals, medical, or news, to improve the accuracy and relevance in those contexts. So, in conclusion, while our research has made significant strides in the Arabic text summarization, there is ample opportunity for further advancements. Addressing these limitations and exploring new research directions would be crucial for developing more effective and versatile Arabic NLP systems. So, thank you all for your listening.